Hello, this is Victoria from Luos, and this is the third part of the ball catcher series! Ooh! No reason for this. In this video, we'll introduce and integrate the Luos engine real-time mechanism called timestamp. In the first step, I have integrated all the components I will use for the ball catcher project. I am using 2 photomicrosensors, 1 solenoid, 1 LCD screen, 2 Arduino MKR0s, 1 Luos STM32L0 based custom board, a power switch shield, and a power supply of at least 8 volts. Up till now we have seen that we can control the solenoid and the sensor using Python and the Luos Python library called PyLuos. However, I decided to transfer the functional part of this project into an embedded application so that I can use the timestamping tool and transform my system to a real-time one. This application will be a Luos service like the drivers that I have already created, and I will put it in the same Arduino board with my sensors. The application will communicate with any other component of my network using the Luos communication protocol. First of all, the application needs to launch a detection, a process that is needed to create a map of the network. In that way, all the services in the system have the information about every other one and they can all communicate with each other. If you need more information about detection and services, you can see the corresponding doc pages or follow the trainings. You can find all the necessary links in the description box below this video. My application will take the value of the 2 sensors every time. When the ball passes through the first sensor, we will send a timestamp message to the solenoid in order to activate it in a specific time in the future. With some calculations depending on the distance between the solenoid and the sensor, I found that I need to activate the solenoid 60 milliseconds after the ball passes. Afterward, the application will be waiting for messages of the second sensor. If the ball is correctly hit by the solenoid, one will arrive. At that time, a message of success will appear on the LCD screen. So let's see the result. The ball was perfectly put into the basket and we saw the goal message. Let's try again. Oops, we missed. Okay, so the result surely must depend on the initial speed of the ball. The calculations that we have already made depend on the assumption that the initial speed of the ball is set to 0. In practice, in a circuit like this, we cannot be sure. This second time I used a small amount of force when I dropped the ball, so the acceleration was not only affected by gravity, but also by the force that I used on the ball, radically increasing its speed. As a result, the ball passed the position of the solenoid before the moment that the solenoid was hit. This setup demonstrates some weaknesses. As the ball won't always have the same initial speed, the time of contact cannot really be predicted. To improve this, we need to know the initial speed of the ball. We'll handle this in the next video. Feel free to comment on our video and add your opinion. If you have any tips and tricks to make something easier, it would be really interesting to have a conversation. By the way, you can contact me on our Luos Discord channel and talk about this project. Stay tuned!